Welcome to KR Educational Dunia. Today we are going to see BTech Basic Electrical and Electronics Engineering subject previous solved question papers with explanation. Okay, today the topic is AC circuits. In this, it is a regular paper on September 2023. And here, if you observe carefully, in 5th B, there are problems, right? In 5th B, there is a problem. Okay, so we'll see that problem. It is a half-wave rectifier. Okay, this waveform is called as half-wave rectifier. And here, 5th B, it is given as determine average and RMS value of a sinusoidal waveform shown in figure. So this is a half-wave rectifier. Okay, here the complete time period is 0 to 2 pi. Complete time period is 0 to 2 pi, and the maximum value is Vm. The maximum value is Vm. So here we are finding the average value. The general solution for x average is equal to 1 by t integral 0 to t x of t dt. Okay, with that general solution we are writing this equation. Okay, so V average equal to 1 by time period integral 0 to t V of t d omega t, as via x-axis they have given as omega t, right? So here 1 by t, what is the time period? 0 to 2 pi. So we have to take a complete cycle. Wherever it is starting, the same waveform is here at 2 pi. Again the starting waveform is there. That means from here to here it is called as one time period, one cycle. Okay, so 1 by 2 pi, 0 to t is 2 pi, so 0 to 2 pi. But here if you observe carefully, there are a different cycle. That means from 0 to pi there is a half cycle, and from pi to 2 pi there is no output waveform, right? That is 0. So we are writing two cycles. So from 0 to pi we are writing equation, and from pi to 2 pi also we are writing equation. So here 1 by 2 pi integral 0 to pi, and for this 0 to pi, this is a sine wave, half sine wave, right? So this is a sine wave. So Vm sine omega t dot d omega t plus, from pi to 2 pi I am taking integration. So from pi to integral from pi to 2 pi, there is no value, no waveform, so 0 into d omega t. So this term will become 0. Okay, and equal to 1 by 2 pi 0 to pi integral 0 to pi Vm sine omega t d omega t equal to, if I take out 1 by Vm constant outside, Vm by 2 pi 0 to pi sine omega t d omega t equal to Vm by 2 pi sine integral sine omega t is minus cos omega t. So minus cos omega t, and the limits are 0 and pi. So minus Vm by 2 pi, applying the limits. So higher limit minus lower limit. So cos pi minus cos 0. Okay, what is cos phi value? Cos phi value is minus 1. So cos pi value is minus 1, minus cos 0 value is 1. So minus 1 minus 1, we got minus 2, right? Here outside there is a minus, inside there is a minus. So minus and minus will get cancelled, and here Vm by 2 pi into 2, right? So this 2, if it goes out, 2 Vm by 2 pi, 2 will get cancelled. So the answer is V average equal to Vm by pi. Now we are going to see RMS values, right? So the general solution for RMS values is x RMS equal to under root 1 by time period integral 0 to t x of t square dt. Okay, from that equation we are taking this general this equation. So Vrms equal to under root 1 by 2 pi integral 0 to pi Vm square sine square omega t d omega t plus pi to 2, integral pi to 2 pi 0 square into d omega t. This 0 square d omega t, this term will become 0. So no need to write this one, okay, as there is no waveform from pi to 2 pi. So here under root Vm square by 2 pi integral 0 to pi sine square omega t d omega t. So after that under root Vm square by 2 pi integral 0 to pi, what is sine square omega t? 1 minus cos 2 omega t by 2. So by into d omega t. This 2 will this remainder 2 will come out, and here under root Vm square by 4 pi integral 0 to pi 1 minus cos 2 omega t into d omega t. So here under root Vm square by 4 pi, now I am applying the limits, okay. So integral 1 minus cos 2 omega t will become omega t minus sine 2 omega t by 2. So upper limit is pi and lower limit is 0. Next under root Vm square by 4 pi, and this term will become, after applying the limits, it will become pi minus sine 2 pi by 2, right? So here after doing this, you are going to get Vm under root Vm square by 4 pi into pi. So here pi will get cancelled and Vm square by 4, right? Under root Vm square by 4. So under root Vm square is Vm, under root 4 is 2. So Vrms value equal to Vm by 2. Here we are going to see some of the waveforms about average value as well as RMS value and its form factor and peak factor. Okay, so here one waveform, first waveform is, we are going to take a sine wave, okay. So here we are going to take y-axis as V and x-axis as omega t, and the maximum value is Vm, okay. And for a average value of a sine wave, we are getting plus Vm and we are getting minus Vm, right? For the negative cycle we are getting minus Vm. So the average value of a complete cycle will be always 0 for sinusoidal waveform. That is the reason we are not taking the complete time period, that is 0 to 2 pi. We are taking only half of the cycle, that is 0 to pi. So here we have to consider the time period equal to 0 to pi. So the general solution for average value is x average equal to 1 by t integral 0 to t x of t dt. So here x average means V average. So V average equal to 1 by time period. I told you, no, time period we have to consider only up to pi for a sine wave. So 1 by pi 0 to pi Vm sine omega t d omega t. Okay, for a sinusoidal waveforms, either it is a half wave, full wave or a sinusoidal, we are going to use sine waves, okay, sine formula. So so here this Vm will come out, the constant value will come out, that is Vm by pi 0 to pi sine omega t d omega t. So integral sine omega t is nothing but minus cos omega t. If this minus comes out, minus Vm by pi cos omega t, we are applying the higher limit minus lower limit. So cos pi minus cos 0. What is cos pi value? Minus 1. What is cos 0 value? 1. So minus Vm by pi cos pi minus 1 minus cos 0 1. So 1. So here minus Vm by pi into minus 1 minus 1, this will become minus 2. So minus will minus into minus plus, so minus will get cancelled and 2 Vm by pi. So 2 by pi is nothing but 0.637. So 0.637 into Vm. Next, coming to the RMS value. We can call RMS value or effective value or voltage virtual value. What is RMS? Root mean square value. So we are going to find out the root mean square value of a sine wave. So the general solution for RMS value is XRMS equal to under root 1 by t integral 0 to t x of t square dt. Okay, So here we are considering a complete cycle for the RMS value. We are not considering half cycle. So what is a complete cycle? What are the limits? 0 to 2 pi, right? So the time period is we have to take for a complete 2 pi, right? So V RMS equal to under root 1 by t. T is 2 pi. 1 by 2 pi integral 0 to 2 pi. Okay, 0 to 2 pi Vm sin omega t whole square d omega t. So that is equal to under root 1 by 2 pi 0 to 2 pi. Separately I am writing Vm square into sin omega t square d omega t. So this Vm square constant, if it comes out, it will become Vm square. So under root 1 by 2 pi 0 to 2 pi Vm square into, so what is sin square omega t? 1 minus cos 2 omega t by 2, right? Sin square t equal to, here I have written the formula also, sin square theta equal to 1 minus cos 2 theta by 2. So by this we are writing 1 minus cos 2 omega t by 2 into d omega t, and under root this Vm square comes out, Vm square by this under 2 is there, no, this 2 also will comes out, it will become 4 pi. So 4 pi omega t minus, so I am applying integrations also, so omega t minus sin 2 omega t by 2, and the limits are 2 pi to 0, 0 to 2 pi, right? So I am applying the limits. So under root Vm square by 4 pi into 2, that is 2 pi minus sin 2 pi by 2, right? So after doing this you are going to get 2 pi, right? So here 2 2s are 4, so 2 will get cancelled and pi will get cancelled, and under root you are going to get Vm square by 2. So equal to under root Vm square is nothing but Vm, under root 4 is under root 2, right? So under root 4 is under root 2, right? Under root 2, that is 1 by root 2 equal to 0.707. So 0.707 into Vm. So I know RMS value, I know average value. Now find out the form factor. What is the formula for form factor? RMS value by average value, that is 0.707 Vm by 0.637 Vm. Vm will get cancelled, and at last you are going to get form factor value is 1.11. And what is the peak factor value? Peak factor equal to maximum value by RMS value. So what is maximum value? Vm by RMS value is Vm by root 2. So you after Vm will get cancelled, and the root 2 will come to the numerator, that is root 2. Root 2 value is 1.414. So peak factor equal to, peak factor symbol is Kp. So Kp equal to 1.414, and form factor symbol is Kf. So Kf equal to 1.11. And another waveform we are going to see. So here this is called full wave rectifier. In the problem they might be asking you draw the find out the form factor and peak factor of a full wave rectifier. Then by default you have to draw this waveform. Okay, sometimes they will be giving you the waveform also. So this is called full wave rectifier waveform. So here the y-axis is V and x-axis is T, and here the maximum value is Vm, and here the time period is 0 to pi. Okay, 0 to pi is the time period. So V average equal to 1 by t integral 0 to t V of t dt. What is t? Pi value, right? So equal to 1 by pi 0 to pi Vm sin t dt. So equal to Vm by pi in brackets minus cos t, and the limits are pi to 0. So minus will come out, so minus Vm by pi into cos pi minus cos 0. Okay, upper limit minus lower limit. So minus Vm by pi into cos pi value is minus 1 minus cos 0 value is 1. so minus 2. Okay, so minus Vm by pi into minus 2, minus minus will get cancelled, and you got 2 Vm by pi. So 2 by pi value is 0.637, so 0.637 Vm volts. And coming to the VRMS, okay, VRMS, the formula is under root 1 by t integral 0 to t v of t square dt. So here under root 1 by t, here the time period is 0 to pi only, because the maximum time period is pi only. So 1 by pi integral 0 to pi Vm square sine square t dt. If they have given omega t, you have to write sine square omega t d omega t. Okay, here we are considering only t, so sine square t dt. So under root Vm will come outside, Vm square by 4, and integral sine square t is nothing but 1 minus cos 2t by 2, right, into dt. So now we are applying, so integral cos 2t dt is nothing but sine 2t by 2. So Vm by pi, okay, Vm by here, so we are substituting these values. Okay, here after substituting these values, you got Vm by 2 root pi in under root 2 pi minus 4 pi, so equal to Vm by 2 root pi into root 2 pi minus sine 4 pi is nothing but 0, so 2 pi minus 0, 2 pi under root 2 pi. So here under root 2 under root pi, so pi under root pi will get cancelled, and here under root 2 is there, so Vm by 2 into under root 2, that is we can write 2 as root 2 into root 2, right, because root 2 into root 2 is 2 only. So root 2 will get cancelled, and we got Vm by root 2, that is 1 by root 2. 1 by root 2 is nothing but 0.707 Vm. So this is the value for RMS. Once you got average value of 0.637 Vm and RMS value of 0.707 Vm, then find out the form factor and peak factor. So form factor Kf equal to 0.707 Vm by 0.637 Vm, that is equal to 1.11. Vm will get cancelled. And next peak factor Kf equal to Vm by Vrms. So Vrms value is 0.707 Vm. Vm will get cancelled 1 by root 2. Otherwise 1 by 0.707 is equal to 1.414. Like that you need to find out the values of Kf and Kp. Okay, coming to the next circuit, this is called square waveform. Okay, square waveform. There are two types of square waveform. This is half square waveform, okay, and full square waveform is also there. So this is half cycle square waveform. So here x-axis is t and y-axis is v of t, and the maximum value is Vm. Okay, so at this point Vm comma t by 2, at this point t by 2. Here if you observe carefully, it is up to 0 to t by 2 we are having cycle, and from t by 2 to t we don't have any waveform, right? So we have to apply two limits. So here 0 to t by 2, okay, 0 to t by 2, the maximum value is Vm, but t by 2 to t, the maximum value is 0, right? So now I am applying a V average. V average equal to 1 by time period 0 to t V of t dt. So here V average equal to 1 by t integral 0 to t by 2. So instead of time period I am taking t by 2. So t by 2 Vm dt. Here we are not going to use sine formula, because this is not a sine wave, at least not a half sine wave, right? So we should not use that. So 1 by t integral 0 to t by 2 Vm dt plus from t by 2 to t. So integral t by 2 to t, the value is 0, so 0 into dt. Anyway, this term will become 0. So we got Vm, this Vm comes out Vm by t 0 to t by 2 dt, that is Vm by t. If we apply the limits, so t upper limit 0 to t by 2. Okay, so if we apply the limits, So Vm by T into T by 2 minus 0. So 0, so T will get cancelled, and finally we got Vm by 2. So here 1 by 2 is nothing but 0.5. So V average equal to 0.5 Vm volts, and Vrms equal to under root 1 by T 0 to T V of T whole square dt. So 1 by T 0 to T by 2. Now I am applying 0 to T by 2 Vm square dt plus 0 to T by 2 to T 0 into dt. Anyway, the term will become 0. So I am not writing that. Okay. So Vm under root 1 by T. So here the value of V of T is nothing but Vm, right? So if you substitute T 0 to T by 2. So Vm into under root 1 by T into T by 2. So Tt will get cancelled, and under root 1 by 2. Okay. That is 1 by root 2. So Vm by root 2, that is 1 by root 2 is nothing but 0.707 Vm. So you got V average value is 0.5 Vm and Vrms value is 0.707 Vm. After that, find out the peak factor and form factor. Here I have found only form factor. So form factor equal to Vrms by V average, 0.707 Vm by 0.5 Vm. I got 1.414. So here these are the sinusoidal waveform formulas which we have seen already, and after that, for the given signal, calculate the form factor and peak factor. This waveform is called Sawtooth Waveform, SAWTOOTH, Sawtooth Waveform. Okay, sometimes they will be giving you in the question directly, they will say Sawtooth Waveform. Then you have to draw this diagram on your own. So if they have given the diagram, it's enough, that's good. Otherwise you have to remember this. Okay, this is called Sawtooth Waveform. X-axis omega t, y-axis v of t, and here the coordinates are maximum value in y-axis is Vm, and here the time period is up to t. So it could, so at this point, okay, the coordinates are t Vm, okay, x and y, x comma y, that is t Vm. Okay, calculate slope. So first of all, y equal to mx. So m equal to, the formula is y2 minus y1 by x2 minus x1. So here for finding the slope, m equal to, that is m equal to y2 minus y1 by x2 minus x1. Y2 means t, y1 means y2 means Vm, y1 means origin coordinates. Origin coordinates are x1, y1, and here these coordinates are said to be t and Vm are said to be x2, y2. Okay, so y2 minus y1, so Vm minus 0 by x2 minus x1, t minus 0 equal to Vm by t. Okay, so V of t, we got the V of t value, that is Vm by t into t. Average value, V average is equal to 1 by t integral 0 to t V of t dt, that equal to 1 by t integral 0 to t, instead of Vt I am substituting Vm by t into t. So Vm by t into t dt. So here V of t is there, that's why Vm by t into t. Okay, so here equal to this Vm and t, this constant will go outside. So Vm by t square integral 0 to t and t dot dt, it is like integral x dot dx. Integral x dot dx equal to x square by 2, right? So Vm by t square into here x is nothing but t, so t square by 2. So t square will get cancelled, Vm by 2. The answer is Vm by 2. V average equal to Vm by 2, or V average equal to 0.5 Vm. Okay, next coming to the RMS value for this circuit. RMS value, Vrms equal to under root 1 by t integral 0 to t V of t square dt. So under root 1 by t integral 0 to t what is V of t? Vm by t. So Vm by t whole square into t square dt. So Vm square t square into t square. Okay, and here Vm by t we have taken out Vm square capital T square is there, so we have taken out from the under root because it is already in square and the constants will come out. So Vm by t under root 1 by t, and here integral t square x square dot dx, so t cube by 3. So 1 by t into t cube by 3, and the limits are 0 to t. So if we apply limits, Vm by t under root 1 by t into t cube. Okay, so instead of t we have to put t, so t cube by 3. So this t and this cube will get cancelled and it will become t square by 3. Okay, under root t square by 3. So under root t square is nothing but t. So Vm by t into t by root 3, right? Tt will get cancelled and the answer is Vrms equal to Vm by root 3, right? So root 3 volts. Here we got V average, we got Vrms value, right? After that form factor formula is RMS value by average value. So Vrms by V average. So Vm by root 3 by Vm by 2. Vm will get cancelled and 2 by root 3. This will become reverse because by 2 is there. This 2 will become reverse and by 3 is there. So by 3, 2 by root 3. 2 by root 3 that equal to 1.154. And peak factor equal to maximum value by RMS value, Vm by root 3. So Vm will get cancelled and by root 3 will become, in denominator by root 3 is there, this root 3 will become in numerator root 3. So root 3 equal to 1.732. So peak factor value is 1.732. For example, if they give problems, they give instead of derivation, if they give problems, so we'll see how the problems we have to write. So calculate the V average and Vrms. So V average they have given in y-axis V of t and the maximum value Vm equal to 20 volts they have given, and x-axis the time period is t. So in x-axis t the maximum time period is 2, right? Here 2 is there time period, right? So I know Vm value, I know t value. So what is the formula? V average equal to so average formula is Vm by 2. So what is Vm? 2. Here Vm is the y-axis maximum value, that is 20 by 2. 20 by 2 is 10 volts, and here in x-axis it is of 2 volts, 2 time period, right? So here Vrms equal to Vm by root 3. What is Vm? 20 by root 3, that is 11.54. If they ask not only V average and Vrms, if they ask form factor, peak factor, substitute these values here and you are going to get the answer. So this is a simple problem, but it will be giving in a long answers. As a long question they are going to give. So learn this. It is very simple if you know the formulas, if you know the final answers for all the waveforms. Next, coming to the another waveform. This is also called square waveform, but it is a full wave. Before we have seen as a half wave rectifier, half square wave. Here it is a full square wave, right? In this full square wave the maximum value is V and time period is t, 0 to t, right? So here for an average value, as here also if you observe the maximum value and the average value of a complete full square wave is 0 only, because plus V and minus V, the average will become 0. So that's why for average we are going to take only half of the cycle. So 0 to t by 2 only we are going to take. So we have assuming t equal to t by 2. Okay, t equal to t by 2, V average equal to 1 by t, integral 0 to t V of t dt. So instead of t I am writing t by 2, because here the time period we have considered as t by 2. So 0 to t by 2 Vm dt. So equal to 2, this denominator 2 will become numerator, so 2 into Vm, this constant will come outside, so 2 Vm by t integral 0 to t by 2 into 1 dot dt here. So 1 dot dt, so here 2 Vm by t in brackets, t in brackets using the limits 0 to t by 2. So applying the limits to the value, right? So t by 2, so 2 Vm by t into t by 2 minus 0, that is t by 2. So t will get cancelled, 2 will get cancelled, so the answer is Vm volts. In the same way, Vrm is equal to under root 1 by t integral 0 to t Vm square dt. So Vm into under root 1 by t 0 to t 1 dot dt, right? 1 square is 1 only. So here Vm into under root 1 by t, here we are applying the limits 0 to t, 0 to t. So the value will be Vm under root 1 by t into t. So t will get cancelled and root 1 is 1 only. So Vm into 1 Vm. So Vrm is equal to Vm only, right? So form factor Kf equal to Vm by Vm, that equal to 1. Okay, this is how you have to do. And here there is a values are there. So if you know the formula directly, you can put the formula. And here the this is half square wave, so here they have given Vm as 20 volts and time period as 0.3. So from here to 0.3. So here you can apply, you can write V average equal to 1 by t integral 0 to t V of t dt, and you can apply this, you can do the calculations. Otherwise, if you know the formula directly, you can put in that value and you can substitute, right? So here V average equal to, see here Vm by 3. So 6.67. Otherwise you can do the derivation 1 by 0.3 integral 0 to 0.1, because we are taking the limits from 0 to 0.1, and 0.1 to 0.3 the value, if you take the integrations, the value will become 0 only. That's why from 0 to 0.1 we are taking plus 0.1 to 0.3. So here 1 by t, that is 1 by 0.3 time period to 0 to integral 0 to 0.1 20, that is Vm dt, plus from 0.1 to 0.3 integral 0.1 to 0.3 the value is 0 only, so 0 dot dt. So this term will become 0. So here this 20 will come outside, 20 by 0.3 into t, and the limits are 0 to 0.1, and here we are applying the limits at the t. So 1 by 0.3 into 20 into here 0.1 is there. So instead of t we are using 0.1 minus 0, that is 0.1. So after doing this, you are going to get the value as 6.67. In the same way, Vrm is equal to 1 by t integral 0 to t Vm square dt. So equal to 1 by 0.3 0 to here we are using 0 to 0.1 20 square dt plus the 0.1 to 0.3 integral, the value will become 0. So I am not putting that value. Okay, the term will become 0, and after that this 20 square will come out. So we under root 20 square is 400 by 0.3 0 to 0.1 1 dot dt, right? So here applying the integrations and we are applying the limits also 0 to 0.1. So instead of small t we are using the limits 0.1 minus 0. So 400 by 0.3 into 0.1 minus 0, that is 0.1. So it will get cancelled, and totally it will become under root 400 by 3, that equal to 20 by root 3, that equal to 11.54. So we got Vrms value, we got V average value. If they ask to find form factor, Okay, VRMS by V average. So put those values, you got value of root 3, and peak factor Kp equal to 20 by root 3, that equal to root 3. This is how you have to find out the values. Hi guys, finally we have completed AC circuits. Here if you really like these videos, if it is really helpful for you, okay, please like, subscribe, and also share to your friends who are studying mainly first year of BTech. And not only that, there are many videos which how you have to gain time while writing the semester end exams, and how to get good marks. Okay, pre and post preparations before going to the exam and after going to the exam. And there are many more videos which are really helpful. Not only that, there are many projects. I hope we have done those projects, and which will be helpful, and entire data along with PPTs and everything I have kept, so you can do by your own. You can practice some of the electrical or electronics projects. Okay, so I hope this video you like the most, and please share, don't forget to share. That will be helpful for many of your friends to get more information. Okay, thank you very much.